Hey everybody, Dr. Adam Austin DC here again, and I'm going to show you today, again in Google Earth Engine, how to use or how to write a code for a time-lapse. Now, time-lapse is a project through Google Earth Engine, which I've shown a couple times before. Briefly, Google Earth Engine is this online geographic information system with all satellite imagery, not all, but I'm sure not all, but most at least, uploaded to servers and accessible. So prior to Google Earth Engine, if folks wanted to use satellite imagery, they would either have to download it via some API or HTTPS, or they would have to download the individual files. But then after that, they would have to go through this process of taking out the clouds, for instance, and other type of work. So what Google did with NASA in partnership was compile all of these data sets together. Years and years of images of the Earth, taken all at different intervals. There's something like 25 satellites that have all their data accessible. And the other thing I'll mention, even though I'm not going to mention it much here, is that right now you're looking at an image of the natural color. So it's comprised of mixtures of red, green, and blue, right? And then you get all these different colors. Now, all these satellites have multiple sensors, and those pick up on different wavelengths of colors. So you can get near infrared, you can get information about cloud cover. They just sent out a new satellite that is specifically tuned to only pick up water. There are ways to manipulate it so that you highlight, for instance, vegetation and even healthy vegetation versus unhealthy vegetation. So right now we're only looking at these natural colors, and that surely can be helpful. But just know that if you get more into remote sensing, and I'm not that advanced within specifically remote sensing, although Google Earth Engine has helped me understand a lot more, that there's a lot more that can and will be done. Like I said, a new satellite was just sent a couple days ago. And the other thing I'll mention again is that the satellites that we send to Mars and the Moon also have that those features. So getting to know remote sensing on Earth helps you, for instance, bring that to, if those are your interests, to the satellite imagery we have from other planets. Now, this project is called Google Earth Timelapse, and basically what they're doing is they're taking all those images and putting them in sequence. I think they start at 1984, yeah, and we have a satellite that basically, the satellite's called Landsat. You can look it up on Wikipedia. I talked about it a bit before. But the Landsat satellite will go around the Earth, right, and take pictures of the same place on the Earth every 2 weeks, which is nuts. Okay, and this has been going on, I think actually it was a coarser temporal resolution, so maybe a month, for some of the older Landsats, but the newest Landsat 8, is every 2 weeks, and they've just gotten better and better. But the result is we have pictures of the Earth from 1984 till today. It's almost a 40-year period, and it's incredibly helpful for Earth system sciences. But also some other attributes. So, for instance, commonly talked about in a more kind of social setting is the drying of the Aral Sea. So here you have it in the 90s through the 2000s. You're seeing, wow, look at that shrinkage, right? And from other waterways. And you can go to, for instance, let's see, this one's a good one, urban growth in Las Vegas. You have urbanization, high urbanization happening in the 1980s. Let me back out a little bit here to get the full effect. So look at the growth of the urban center in 1984, and we're getting bigger and bigger. 2000, there's a big boom. By 2020, we're maybe triple the size. Now watch Lake Mead, and how much smaller it gets. Obviously, water in the western United States big issue, big natural resource management issue, and here you're able to visualize why that is so. We have the building of the Bay Bridge is pretty interesting. The one I think is also super interesting. Where is it? No, irrigation in Saudi Arabia. Saudi Arabia, obviously, mostly desert nation, and they decided they do not want to rely solely on international sources for their food, so they built these huge irrigation pods. And I mean, check out that expansive area of land now devoted, completely converted with farming. And I don't know the source of this, but there's a master's thesis, a high school paper for sure, in understanding this. And this image is a really nice way to visualize it. Now, I love time-lapse because it's of the entire Earth, right? So I can go through Egypt. Let's see, there's Turkey. I can go through anywhere and kind of check it out. So I always, of course, go to my little suburban New Jersey home, and I think you can see it just right from here, the amount of so here's the 1980s, and look how much farmland there is. This is the Garden State days. By the late, I mean, it happens almost so quickly, and of course you can slow things down a little bit. But by 2000 and, oops, yeah, there you go, the late 2000s, wow, look at suburbanization and the effect that it has on the amount of agricultural land. Now, obviously here we're just visualizing, but certainly we can do actual analysis to, for instance, measure how much greenness is lost in these areas, for instance. Just going to look one really quick. You see all the buildings popping up. It's a little movie. It's cool. Now, if a kid wanted to show this in a project, you might have them just zoom into the area, remember the link. That could be a little bit annoying. So what I've done is I found the code online for you to work with. I'm just going to walk through the code. I had written something that it was a little bit more complicated than what I found from another source. So I'm just going to copy and walk through it and give a little bit of example. Because I think we all want our students to be not necessarily just consumers of technology. Oops, sorry about that. I'm also babysitting, so babysitting my own baby. So not really babysitting. Fatherhooding. Hey buddy, how you doing? So here is code.earthengine.google.com. Again, you can register for an account for free if you'd like. You see it saves all your scripts, which is really nice for geographic analysis. There are also a bunch of example scripts that you can use to kind of steal from. I'm going to quickly run through how this code works. And you know what? I'm just going to, in some of the past code, I've just typed it out. For me, that's not always how code goes. Sometimes I do find something on the internet that I can just copy, modify, etc. And that's what I'm going to do, just to save a little bit of time. And I'm providing the code, excuse me, in the blog, so you can get it right there. So the first thing I need to do is draw the area that we want to highlight. And I'm going to pick Phoenix, Arizona. I'm going to pick it because I read there's a really interesting water history there. Now, I'll note this is pretty big, so probably at the end of my video I won't have the file, but I will upload the file so you can see it. But if I was only going to do a small little neighborhood in Phoenix, that would be one thing, but this kind of water insecurity and water issue does not happen at this kind of local scale. Certainly it does, but in terms of the visualization, we have to have the water sources, obviously. So I've imported geometry. It's a polygon. And now I have to import a couple more. First thing I'm going to do is Landsat 4. So, and I'm going to pick tier 1, import. And I'm going to call this one L4. Now, again, we have to pull, there are different satellites that have been going on for different periods of time. Landsat 4 started in the 80s, Landsat 5, I think the later 90s. You know, I'm not sure the exact time frames here. But what we're going to have to do is compile all the images from all these different Landsat image collections. You see that's what they're downloading here, to put them in sequential order if we want that time span. If we only care about like 2010 to 2015, we might be able to just do that on Landsat 7, but you know, you can modify as you will. So here I'm going to do the same thing. I'm going to do it for Landsat 5. See, it has the nice description, and then it has the image properties here, which you could call if you're only interested in those types of things. But you can see how many bands and how much it shows. Look, temperature, radiance, etc. Okay, L5. You know, I'm not sure exactly why, but oh, that's why. Landsat 5, I think, was merged with Landsat 4. And then Landsat 8. There we go. Okay, and you know, if you don't want to go through that process, that code is also provided, like I said, on the blog, so you can use that. So here we're defining a period of time. So again, if you only care about a couple of years difference, you don't need to do this, but here we state, so basically Earth Engine has its own package. Again, this is or I'm only saying again if you've seen this before, or these videos before rather, but JavaScript is kind of the basis of Google Earth Engine. So you're pulling from the Earth Engine library and you're listing in sequence 1988 to 2016 by an order of 1. So if I printed years, then on the console it'll show 1988, 1989. Now we don't really need that, so I'm gonna just toss that. So these next 8 lines of code, and I know this can look intimidating if you're not really in the coding world, but it's actually very rudimentary, is we are naming the bands. Naming the bands, like the Beatles. Just kidding. So that's all we're doing here, is saying that these are the different, like I said, these are multispectral sensors, and they have different bands, for instance, red, green, blue. Put that together and you get kind of the natural image of the Earth, but like I said, there are other sensors and other bands that you can choose from, and here are their names. But, you know, I assume you can only show, for instance, the time period where all of these are available, so it'll red, green, and blue will always be available, but, you know, it looks like over here, I forgot how to say that word even, but the pan won't be able to be seen for Landsat 4 or 5. So now here, I'm going to filter the images based on my geometry, which is, you guessed it, right over there, variable import geometry, my polygon. So this image collection that I'm pulling is actually the whole world, and I don't need that. So here I'm going to filter to only get images that touch that boundary. Now here what they're doing is removing clouds. Like I said, that was a big part of remote sensing before, is removing clouds. I would just if you're using this with students, I would make sure you're using it with older students and tell them not to really mess around with this much. The only variable that they might want to mess around with is this cloud threshold. Basically, this is saying only pick pixels and thus images where there's not clouds obstructing your view. But if you're looking at a phenomenon like fire, for instance, you might want to like lower that threshold so that you're getting as many pictures as you can. And then here's where you're going to only select images that meet that criteria you set for your cloud function. Okay. You can see here, this is where you're setting the cloud threshold, and here's where it's used. So there. And you are going to, we're again going back to the band names. You're just naming those bands based on the variables you set first. So you can see these are strings. That means they're just kind of like read as B1. Trying to think of an example where, so if the B wasn't there, it could just be one, and if it was in quotes, it would be obviously or it would be a string, but it could be an integer if it wasn't in quotes. So then, what we're gonna do, we have put the images through our cloud function. We have selected only the ones in our geometry. We have named all the bands that we're gonna use. Then we make a collection based on those images. So you can see we merge the L4 images, which are these, with L5, L7, and L8. Now again, we're only going to be selecting red, green, and blue, but maybe I'll like play around with it and after we do the initial example. Yeah. So here, I make a yearly map, that's the variable, and what we're going to do is from the time of the system start, it's going to go by year 1 in the calendar range. And it's only going to pick the median image. So we got all the good images, and it's only going to choose the one, I guess, midway through the year. Because we're only going to see one image per year. Now this next, the next code, I don't really understand all of it, but what it is essentially doing is changing this into an 8-bit image so that it could be used in the video. And here I'm going to change the name of the video to Phoenix. Oops, there we go. And you can kind of modify these if you want the video to be a little bit different. So then all you have to do is press run, and then you'll see in your tasks that this shows up as Phoenix, and you can press run there. Here again, you see all the defaults that you saved. You can either save it in cloud storage or right here in your drive. And I'll just run it right now. This will probably take something to the order of 2 to 3 hours, so I will upload it later for you to see. But I think that these videos could be really cool in guiding projects, in informing us a little bit about satellite imagery. I would want to make sure actually that I have all the information I need before messing with the bands that we're going to see. But if you wanted to see, for instance, only changes to vegetation across certain areas, that's something you could do with modifying the bands in some way. Honestly, if anyone modifies this and wants to put it in the comments, would love to see what you got. But for now, shoot me a comment if you have any questions. Thank you to, she'll put her first name, Danielle, for posting this code, because I think it's a really useful code. Oops, what happened here? Is it too big? I haven't tried to do what we're gonna do. Now this, how's that for on the fly? I bet that this width is even too big. Part of the reason it might be too big is because I don't pay for this Google account, so I'm sure if I did, then it would be a little different. You know what I could show? I could do this separately with 3 videos, because this is one of the water sources, this is another, and this one shrinks dramatically over the 40 years, I'm sorry. This one actually grows because they put a dam, and then I can just get one of Phoenix, maybe even a little zoomed out. But for right now, I'll just run that, and then actually this would all be a bit faster, so my apologies. I'm going to call this Phoenix 1. And I'm going to say run that. Move that over here. I'm going to call this Phoenix 2. Run that. Part of it is the meters per pixels I could change. Well, I'd keep it for that one, but then what I can do here is make this a little bit broader. That's what I'm going to do. It's going to be awesome, actually. I'm going to change this so that it's 200, or I'm going to change it to 300 meters per pixel. So that should run a little faster, and I will upload these when it's all done. Thank you guys for watching. Again, you can go to Timelapse if you're just going to use that. I will put the link there, earthengine.google.com/timelapse. A wealth of material for you to focus in on and learn about changes to the Earth, which is related, of course, to environmental science, history, social sciences, etc. Thanks very much. Have a great day.